What if we had a test today? What if there was a test today and these kids were just down there fishing? I don't care. I'm gonna send this to Mr. Schimpf so he can listen to it. Okay, so if a line is parallel to one side of a triangle and intersects the other two sides, then it divides those sides into proportional lengths, which means if you have a line that's parallel to another line, then we can say that this segment over this segment is equal to this segment divided by this segment, which also works. Remember that you can switch the means and the extremes. That you could also just say this segment over this segment is equal to this segment over this segment, like whichever way it makes the most sense to you. So that's the same as saying AB over AE is proportional to BC over EB. Because remember, as long as you're multiplying AB and EB, it's the same thing. So whichever way you see it, which means we can just do a lot of problems now. So then triangle RST, RT is parallel to VU, SV equals 3, VR equals 8, and UT equals 12. Find SU. Close stuff. But do you see how we can just set up a proportion here? So we have two options. Doing the way the book says, we're going to take this side over this side. So 8 over 3 has to be proportional to the other two sides, big to small. So 12 over X. Or if you like it better, you could do 8 over 12 equals 3 over X. I don't care which way you see it as long as you know the rules. And then you just solve that, right? So 8X equals 36. Oh, it doesn't work out nice. So then we can say, divide by, what do we divide by? 4? 9 over 2, which is 4.5, which is 4.5. I'm going with the fractions. My new goal in life is to get you on the fraction kick and away from this. 4.5 is okay. That's not bad, right? But you got to know that theorem. Otherwise, no way to test. Yes, we like fractions. But this one's okay. It's not a bad decimal, so you can be a decimal lover. I'm not a decimal lover. I discriminate against decimals. The only thing I discriminate against is decimals. It's decimalists. No, it's not. I'm the only person that cares about fractions and decimals. I like to say fractions are a friend, decimals, blah. That's it. That's all I got. Then here's the problem. I like brainwashed you to always want fractions. But then sometimes in story problems, like giving a decimal answer makes more sense, right? Saying that you traveled 147.2 miles probably makes more sense than writing that as an inverse fraction. So there are times when decimals are okay, but the majority of math, fractions are better. I'm on team fraction. Alright, the converse of this. Remember, converse just means we switch the hypothesis and the conclusion, which just says if you know the sides of the triangle are proportional, then that's enough to determine that the lines are parallel. So it says, given this lovely picture, that DH equals 18 and HE equals 36 doesn't seem like that's strong to scale. And that DG equals half of GF, whoa, that's tricky. Yeah. Is that parallel? So I'm not going to write anything over there. If I did this side over this side, do you agree that's the ratio 18 over 36? If I did VG over GF, you don't like what I did. If I did DG over GF, do I know what DG equals? Yeah, so instead of writing that, could I say 1/2 of GF over GF? Does DG equals 1/2 GF? GF stays GF. And can I cross GF out? Maybe that's a whole lot more work than I need to say. What does 18 over 36 reduce to? And if I cross all this out, what's left over here? We kind of just did a proof without like describing every step. If we can prove that these ratios of the sides are the same, then we have proved that these two lines are parallel. So we can say, yes, explain. This work is kind of the explanation, but I'm going to just say yes because sides are proportional. Good. Over half the class, they've been gone over half the class. Just want you to do. Or they just want to get out of class. Okay, the mid-segment of a triangle. The mid-segment of a triangle is a segment that joins the midpoints of two sides of a triangle. So it's like in the middle, mid. So you can see in this lovely picture here, they've drawn in one. So if they drew in the midpoint of FH and the midpoint of HK, and they connect it, it will always be parallel to the other side of the triangle. So the side it's not touching, it'll always be parallel to it. And kind of cool, it'll always be exactly half the length of that other side. So in a triangle, there are really three mid-segments, because you could connect the midpoints of all three sides. Like I'm going to do that for all these. And let's say that's the midpoint for there, so you could draw in that, and it would be parallel to HG, it would be half of HG, and then if I connected the midpoint there, then that would be half of FH, and it would be parallel to FH. So sometimes you're going to see the next picture, maybe you've looked at it already, it looks a little scary, but don't get overwhelmed by it. Just look at what they tell you and know if it's a mid-segment, it's half the length of the other side, and it's parallel. It's not really a lot of work to do, but when you look at this, it kind of like, whoa. You ever watched that show, Blossom? That was probably before you were born. Whoa. That's Joe and Blossom. My new goal this week is to just bring in some random fact from an old show that you guys don't know. I told my husband about the Island he was called that he didn't know. He didn't know that. What is it again? Lucy, you got some explaining to do. I didn't tell him about the snake in Obama. I should go watch the rest of that video to see it. In the figure, DE and EF are mid-segments of the triangle. Find AB. If we know ED is a mid-segment, do you know what AB is? It's 10, right? Which if you know that theorem, you don't have any work to do. If this is 5, then this is half the length of this, which means AB equals 10. They didn't ask me this, but do I know what FE equals? What would it equal? Because if this is 18, this is half of it. A couple more theorems. Proportional parts of parallel lines. That's a mouthful, right? Say that straight like that. Proportional parts of parallel lines. If three or more parallel lines intersect two transversals, and they cut off the transversals proportionally. Basically, you can just think that you could, the same idea with the triangles applies here. So if you have three lines that are parallel, you could say that AB over BC are going to be proportional to EF over FG. Or, just like we said in the last one, that's the same as saying AB over EF is proportional to BC over FG. Corollary, do you remember what the idea of a corollary is? Hi boys, thanks for joining us. not to have you. You should watch the video and hear me yelling. I wrote an angry email to Mr. Schimpf already. It's sent already. I used the exclamation mark and all caps. Absurd. I wrote thank you at the end. I only used all caps with one word. Still was in all caps. It is 12:56, and I have students still at the Bass Fishing Club meeting.
Don't blame us. It really wasn't our fault. You just kept talking.
109. What time do we get out of here? 22. How many minutes do you have left in here? Absurd amount. Not enough.
Pretty sure 11.
So, just, you need to know you should have missed my class.
Well, if you want to miss that school,
I would have liked you went to the meeting at 12 o'clock since you have sea lunch and you could have went to the meeting at 12
I
o'clock.
have lunch. I honestly
Matt said
didn't
you have
know
seen
we
it.
had to go now. And I didn't know we were taking a class. I thought it was going to take 5 minutes.
I'm really not mad at you. I'm mad that they had a meeting at 12 o'clock.
It is.
I'm mad that no other group meets at 12 o'clock or 12:30, so why is this group meeting at 12:30? That's what I'm mad at. My email said, I think these meetings should happen before school or after school or prime time, so that my students aren't missing my class. Thank you. Tiffany Dixon. Oh well. Hopefully they get the tone. They need the tone.
Other officers are very
I want to have math team meeting in the middle of English class then.
No, I don't like anybody to show up, though.
Okay, so remember that a corollary is something that makes sense because of the theorem. So if you know this is true, that these sides are proportional, this says if you have your parallel lines, we know the sides are proportional. If we know AB is equal to BC, and we know these are proportional to this, does it make sense that EF has to be congruent to FG? Because if they're proportional, and we already know these two are equal, that means these two are equal. So again, the hard part about when we have our test next week is you have to know what this is saying. EF and FG are the same. We're just looking at side lengths, not angle measures. Okay, so look at this lovely problem. In the figure, Larch, is anyone's name Larch? Oh no, wait, it's a street name. Phew. That was a person's name. I was like, that's a weird name. But I'm Nuthatch Street. Larch, Maple, and Nuthatch Streets are all parallel. The figure shows the distances between the city blocks. Find X. So here's where you just have to know that these are proportional. So you can say 26 over 13 is equal to... Well, 26 over 13 is equal to 2 over 1. But you can match, right? This over this is going to be proportional to this x over 16. Or Lucas is so smart that he sees that this is just half of this number. Like he's doubling this number to get 26, so he's saying he doesn't need to do the proportion. If he can just double 16 to get that, that works out really great when it's a 2-to-1 ratio. But if it was a crazy weird decimal, you might want to throw the proportion. But I think you should get 32 as your answer. I'm not reading it right now. Oh my god, I know there's It's alright. You know what's great about teaching a subject that there's a shortage in? It's going to take a lot to get me fired, so.
We're putting the ball up first.
Like my... I feel pretty secure in my job. That's okay. Probably. I'm not really mad at you guys. I'm annoyed because I don't want you to miss my class. Because I think my class is important. I know you might not, but I think my class is important, and I don't like you to miss out. We didn't have a homework quiz today because you were all missing. So, 4, 5.
I was honestly, like I said, I was 3 minutes.
I know. know, me too. That's why I didn't send the email till 12:56. Like, I gave you time. But then, like, the longer you were gone, the angrier I was getting. This is all on the recording right now of me saying I could not get fired. So when I get fired, you guys can play this back and laugh.
This guy's
Okay, find x and y. Again, without your notes on a test, you have to say, okay, well, normally I would say this over this equals this over this, but they're both x's and y's. So what do I know? If this is marked and this is marked, could I set up an equation to solve for x? So it just means those are equal to each other, right? So I could just say 3x minus 7 equals x plus 5. Subtract x over, we get 2x. Add 7 over, we get 12. So x equals 6. We could do a lot of work to solve for y, and that we can set up a proportion. But if you remember that last corollary, if these two are equal, what do we know about these two? They're also equal, which means you can also just set 9y minus 2 equal to 6y plus 4. Subtract 6y over, and we get 3y. Add 2 over, and we get 6. And we get y. It's not so bad, right? Is that all my examples? We never have time left.